Okay, here we have a stoichiometry problem. We have the organic compound that's made of carbon, hydrogen, and chlorine. 1.5 gram of sample was used, and we observed 3.52 grams of carbon dioxide was formed. And in another experiment, chlorine in the 1.0 grams of sample was converted to 1.27 gram silver chloride. We have to find the empirical formula. So empirical formula looks like this, except the the, the subscript has to be in the lowest ratio possible, and they also have to be integer. Let's start out with finding the percentage of carbon. To do that, we're gonna start out with 3.52 grams of carbon dioxide. That must be converted to mole to use the stoichiometric ratio. Carbon dioxide has 44.01 grams of molar mass. You can find this from the periodic table. And then in 1 mole of carbon dioxide, you have 1 mole of carbon. From that, you can find the mass of carbon. Units cancel out, and you have 0.961 grams of carbon. Then you can use this to find the percentage of carbon by using our sample mass. And times 100%, you get carbon percentage in our sample. That turned out to be 0.64%. So moving to second step, we're gonna use the next sentence. In a separate experiment, chlorine was used to make silver chloride. 0.127 grams of silver chloride was formed. Find the molar mass from the periodic table. Get 143.32 grams, and you have 1 mole of silver chloride. In 1 mole of silver chloride, you find 1 mole of chlorine due to their 1-to-1 ratio. Find the mass of chlorine. Again, you can find this from the periodic table and cancel out the unnecessary units. You're gonna get 30.314 grams. That much of chlorine make up in 1.00 grams of our sample. When you multiply this by 100%, you get 31.4% of chlorine in the sample. And finally, they don't tell you the percentage of hydrogen. However, you can find it from subtracting these two from 100%. Our compound is only made of 3 elements. So what we're gonna do, our total minus percentage of carbon minus percentage of chlorine, you get percentage of hydrogen. That was 64%, and that was 31.4%, and you get 4.6%. If I keep a few more decimal, it should be 0.0458, but it's okay if you keep it 2 big. Next step, after finding the relative ratio in the original sample, you can find uh, the empirical formula by assuming 100 grams. So our step 4 is made of assume 100 grams. You can choose any mass you want, you just have to be consistent with the ratio. But 100 gram is very easy to use since we use the percentages. If the sample is 100 gram, we found the carbon makes 64%. That means 64.0 gram is found in this sample. You can convert that. Okay, first I'm gonna write down these grams and then I'm gonna convert it. 31.4 grams of chlorine and finally 4.58 grams of hydrogen. 12.01 gram carbon should be on the bottom so that I can cancel out. You have 1 mole of carbon and you have you use the same method. You should get the lowest. You should get the number and then we're gonna divide by the lowest of these. Turned out to be you have 5.33 moles of carbon present in our sample and you have 0.88575 moles of chlorine. Finally you have 4.54 moles of hydrogen. Step 5, divide by the lowest mole. Looking at this, our good candidate is this. 0.88575 is the lowest out of this. So if you divide this by its own number, you're gonna get 1, right? Okay. When we divide this by 0.88575, you should get around, I'm gonna use different color. You should get around 6.02, and if you divide this by 0.88575, you should also get about 5.14. Now this is not really, the 0.14 is not really good to round down to 5, but looking at this formula, it doesn't, this is good to assume 5 for now. Because if you try to make this integer, then we're gonna have a really big number here, and usually the problem doesn't ask us that way. So we identified it. Our lowest ratio is C, okay, it has 6.615, C6, H5, and then finally Cl. That's our organic compound, and it's the only empirical formula. So if the problem asks you to find the molecular formula and they give you the molecular mass, then you should divide this number and see the relationship. see the ratio that gives you, and then you just have to multiply that ratio to each subscript.